The results for both a simple overload or a complex mission profile are in the overload section of the results page. The overload results are subdivided into graphs for the overload cycle of the devices with the highest temperatures, which are typically of highest interest, and a details section where one can find losses and temperatures for all switches of the circuit. Here, the cursor is set to the moment where the temperature is highest. This is also the temperature shown in the above bar diagrams. The maximum temperature for the individual switches can be found at various times, depending on the conditions defined in the mission profile. However, in our example, the IGBT and its corresponding freewheeling diode has its hottest moment simultaneously in the last period of the overload cycle. Let's have a closer look at some details. We can zoom in on the X dimension by selecting a time segment using the left mouse button. Now you see areas with gray and green-gray background colors. Here, the simulator has switched between two different simulation methods. In the first and the last section, the simulator operates in the so-called discontinuous mode. Only single periods in large intervals are calculated. The dark and light red curves represent an envelope of the maximum and minimum junction temperatures. This mode optimizes simulation speed. In times of rapid change, the simulator switches to continuous mode. Losses and temperatures of all switches are calculated continuously according to the voltage and current waveforms. This mode offers increased accuracy. The reset button may be used to return to the complete profile. In the details section, you can find losses and temperatures for any switch in the circuit. You can select the switch of interest in the corresponding drop-down menu. T1 stands for top side switch and the /1 stands for phase 1 or phase U. T2 stands for the low side switch and /2 or /3 for the phases 2 and 3 of the inverter. If you select, for example, T2/1, which means the low side switch of phase 1, you get the temperatures and the power dissipation of that switch. This is especially useful at very low frequencies, or 0 Hz, where each transistor has a different behavior depending on the phase shift. You can then use the cursor to select a specific point. Here, for example, the last point of the discontinuous simulation during overload. Additional windows with the temperatures and average losses of the selected period then appear. If you click in the green-gray area of the continuous mode simulation, the windows below show the instantaneous values at the selected time step.